So let us look into some more properties of similar triangles in this video. And one of the properties says this: if two triangles are equiangular, the ratio of the corresponding sides is same as the ratio of the corresponding altitudes. So say again, let's have two similar triangles. These are the two similar triangles, and let's name them ABC and say this is the altitude. An altitude is always a right angle to the base on which it stands from. So let's name this, say, L. Say we've got another altitude from here. Let's name this triangle DEF, and let's name this M. So now what this statement says is that, again, it's not very different from the previous properties of similar triangles that we did. It's just that this vertical line here we're talking about is called an altitude, whereas the previous ones we spoke about were medians and angle bisector segments. So here we know that these two triangles are equiangular, right? So if these two triangles are equiangular, the corresponding sides of these two triangles are proportional, or the ratio of the corresponding sides is equal. Now, not only the ratio of the corresponding sides is equal, also the ratio of the corresponding altitudes is equal to the ratio of the corresponding sides. Or in other words, the ratio of the corresponding sides is same as that of the ratio of the corresponding altitudes. Say, for example, we've got AB by DE, and say if it is equal to BC by EF. It's not only equal to, AB by DE is not only equal to BC by EF, it is also equal to the ratio of the corresponding altitudes. The altitudes here being AL and DM. So that is what this property says. So now, if you're wondering why these things, well, these things are definitely going to help you save a lot of time in solving problems based on similar triangles. Let's quickly look into another property based on similar triangle. All right, so let us look into this other property. So what this property says is that if one angle of a triangle is equal to one angle of another triangle, and the bisectors of these equal angles divide the opposite sides at the same ratio, then those triangles are similar. So say what it says is, say we've got one triangle, and say we've got another triangle, and say we've got an angle A here. Let's also name this triangle ABC. Say we've got an angle D here. Let's also name this triangle DEF. And say angle D is bisected by a line. And in this triangle, say angle A is bisected by a line. Now, the conditions are angle A is equal to angle D. That's what it says. If one angle of a triangle is equal to one angle of another triangle, that is, if angle A is equal to angle D. And then the bisectors of these equal angles, the bisectors in this case are, say, AP and DQ. Let's keep it like that, AP and DQ. Now, if these bisectors divides the opposite sides in the same ratio, that is, the opposite sides are BC and EF. Now, if it divides the opposite sides in the same ratio, that is, if BP by PC equals EQ by QF. So if these bisectors of the equal angles divides the opposite sides in the same ratio, that is BP by PC, if this ratio is equal to this EQ by QF fraction ratio, then these two triangles are similar to each other. That's all. A pretty straightforward property this. Again, why remember this? Because it's definitely going to help you save a lot of time while solving a lot of problems based on similar triangles. So this concludes this property as well as ends this video. I'll see you in the forthcoming videos with more properties of similar triangles.